Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about gRPC, a way to get data across the wire. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett. Episode 413, recorded November 29th, 2016, gRPC. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and not aware of it, which I bet today is going to be a little bit of. Projects you may want to find out about right after the show. And again, this project this week may actually be one of those as well. Joining me this week, Jonathan Bennett. Welcome back to the show.
Hey, thank you, Randall. It's good to be here again.
Very cool. And where are you speaking to us from? It looks really familiar.
Yes, it's corporate headquarters, the home office here in Lawton, Oklahoma.
And no earthquakes to speak of this week, so nothing to report there.
Nope.
Any fracking going on nearby?
I'm not sure. I think they've actually stopped a lot of that because the theory is that it's causing the earthquakes. I don't know, but I think there is quite the effort to stop fracking in Oklahoma.
Yeah, that'd be a good plan. Well, I know they want all the coal. They want it. No, it's not coal. They're getting oil, right? Not that. They're getting natural gas and all that stuff, which is all good stuff for us to have here in the U.S. So we don't have to get it from other people. But now let's not digress this into a climate change or political show. So I am speaking to you as I did last week when it was my birthday show. I'm speaking to you from my brother's den. And for those watching the videos, you can see the big 12 on the in the back of me, which is the 12th man stuff for the Seahawks. Go Seahawks! Although Seahawks didn't go so well last Sunday, so it sort of sucks. All right, hey, so we've got a show today, and otherwise, Jonathan, we'd just be chatting about random stuff. Today's show is gRPC. gRPC. So it is the, of course, RPC. Most of you may be familiar with that term as remote procedure call. And the thing about a remote procedure call is it lets you have data in one application being able to be serialized, if it's like complex, like an object or an array or a hash or something like that, and then used over at another operation. And so Google didn't find what they wanted, and so Google created their own, and it's based on their own protocol buffers, which I've used in a couple of applications before. Jonathan, what do you know about this so far?
Not very much more than what you said. I understand the need to be able to do inter-process communication. You've got one thing running, it needs to talk to something else, and the idea of a remote procedure call, part of it at least, is to be able to make those two things talk to each other. One of the big ideas is to be able to go from one machine to another machine, which again is important, especially when you're trying to scale some sort of process up to run on multiple servers. So I'm very much interested to learn more about it and to see how they handled it.
Well, and a couple of things that are really important about RPC, and one of the questions I have, which I'll save when our guests actually come on, is I'll just save it. Why would I even bring it up now? Hey, let me theorize. But the big thing about doing a remote procedure call is, as I said a moment ago, is to be able to deal with serialization of complex data. So data that is, key value pairs from something like Perl's hash or associative array or whatever you call it from other languages, but also just complex data structures and especially objects that have named fields, to be able to get that from one language to another and have it make sense. And I'm sure part of this talks to Go, because that's one of Google's favorite language. I'm surprised I didn't see Dart in their listing of languages yet, but I'm sure somebody's going to create one pretty soon. But the other couple more important issues, which is high availability, being able to talk to the new one now that the old one's gone sideways and the new one's taken over, and also service discovery. So like I want to talk to the thing that's currently providing mail sending. So who do I talk to out here? And that's all parts of things that you have to do with good remote procedure call interfaces. And I'm sure our guests, which I'll bring on in just a second, are going to be able to talk to us about how gRPC solves all these issues. So let's see. I guess we'll just go ahead and bring on our guests. Varun Talwar, welcome to the show.
Hey, Randall. Thank you.
Hey, and where are you speaking to us from?
From San Francisco, Google San Francisco office.
Oh, very cool, very cool. And we'll also bring on Jayant Kohli, close, I hope.
Kohli, glad to be here.
Kohli. Okay, great. And where are you speaking to us from?
I'm speaking from Mountain View Google office.
In the facilities that used to be SGI, in the old weird buildings?
Yes.
Yes, I've taught many a Perl class there, and the first time a Google friend of mine invited me to go to the head campus, I had no idea that it was actually the old SGI building, and I gave a Google talk, and it was in the very same place that I used to teach classes. And so they said, well, the bathrooms are over there, and I go, I know. I was like, how do you know? And I go, because I used to teach here at SGI all the time. So anyway, enough of that. So let's start with Varun. Give us the 30,000-foot view. What problem is gRPC trying to solve?
So gRPC is an open source universal high performance RPC framework, as that's our tagline, and it's trying to solve the problem of making connecting and operating distributed systems easy, right? So that's our mission with which we operate. We're trying to make developers, companies' lives easier when it comes to, some systems talking to some other systems in reliable ways, and in ways that they don't have to do a lot of heavy lifting around serialization, reconnections, retrials, cancellations, and a lot of that is something that a framework can take care for them independent of whichever language they are operating in.
Okay, and how long has this been around?
It's been around for about a year and a half, I would say, since it's about middle of 15.
And I see that it had a 1.0 release, I guess, about 6 months ago, was it?
Yeah, August this year. Yeah, so slightly
okay,
less.
Good. Oh, my math is almost right. Actually, no, it is not. About 4 months, but that's okay. I'm forgiven. I'm getting old now. So Google invented this to solve their own, scratch their own itch. But aren't there already a number of libraries in this space?
Yes, there are. And I think what's to be noticed is Google open sourced it. A new version of what they were using a year and a half ago. But, Google wrote a version of RPC for their own use many years ago. But, when Google started back in 98. So really we've, from a backend perspective, Google has had an RPC framework, what internally still runs is called Stubby. And, Stubby comes from the word stub, which is, something everyone who learns RPC learns. So, and that's, what we use dates back 15, 16 years ago. This is our open source rendition, learnings from the last, 10, 15 years have gone into this new open source version of it.
Cool. Jayant, let's jump over to you for a second. So you were one of the founders of this project. What had you decide to shift from just using internal materials to actually publishing this as an open source project?
So over time, if you see at Google, we've started open sourcing a lot more projects. TensorFlow, gRPC, Kubernetes are a bunch of these things. And what we realized over a long period of time is we built a lot of good technology, didn't take an extra mile to open source it or build it in open source, and then different variants came up. And it just fragmented the overall open source world and how people are using. For example, we had built Bigtable, there was a HBase built, MapReduce, there was Hadoop. So there were lots of such things and so with that we realized that we need to build it in open source so that the open source marketplace is not as fragmented as it is today. So that was one of the reasons. And the second reason was we did want to ask people to build Google-like microservices in our Google Compute platform. And we thought it would be good to give out some of the things that we have built so people can build their own microservices the same way and scale them.
Okay. First, I do want to back up a step and applaud Google for open sourcing so much stuff. I mean, I know a lot of the things I'm using and for my various clients ends up being maybe traceable back to Google in various ways sometimes. So let's talk about how this RPC. Can you give me a more detailed description of how this is actually working? I mean, what do I see in my code, and how does it help me that this thing is doing something called RPC?
Yeah. So typically, when you want to scale, you want to build a service and then you want to scale it. When you want to scale it, you want to split different modules of this service into different components and communicate between these. RPC basically allows you to request a service from a different program running on a different computer in such a manner that you don't have to worry about any networking details, etc. underneath. So you don't need to know how to connect to a service. You don't need to serialize the data, etc. So so we've built a RPC system which looks like a procedure call, and we've also integrated with a service definition in protocol buffers, and it can be integrated with any other service definition. But what that gives you is you can, in an ideal, write your API service contract where you can have methods like create bank account, deposit money into bank account. And we generate code from this across different languages. And so in your code, you end up using function calls like this stub create bank account. This stub. So it looks very natural, idiomatic to people as if they're writing their program in a sequential manner on a single computer. But effectively, it connects with different services and uses it. So so it hides all the network communication, and it from the API service contract ideal, it gives you a higher level functions which look like what your logic would. And so you can focus on your business logic or application logic.
So for someone maybe like 20 years older than you, they might remember terms like Corba or XML RPC and things like that. How is this different? How is this better? Well, I hope you know something about the things that preceded this, but maybe you don't.
Yeah, so RPC is an old concept. It's a standard operating system concept, started in 70s, and there have been different XML RPCs, Corba, etc. Typically, all of them were very heavyweight, and they opinions, but they became very heavyweight. With gRPC, we have tried to keep the benefits of RPC where it looks like a remote function call. It is very easy to use, but also is very lightweight and doesn't accumulate a lot of craft. And so we've used an RPC system called Stubby for 10 plus years. All of Google is built on it. So we have a lot of background in what we have learned out of this. We've built search, ads, maps, storage, all the infrastructure, YouTube, everything using Stubby. And we've taken those lessons and applied those to gRPC. And that's why we are fairly confident that gRPC is a good solution for inter-process communication.
Very cool. And just to get Varun talking again for a second, so what? Where was I going to go with that? So I know in things like Corba and something, you had to, or XML RPC in particular, you have to publish the layout of what you expect for a remote procedure call in XML, unfortunately, which nobody should be required to even look at, let alone edit or anything else. But that's my aside opinion. Is there something similar here? I mean, how does somebody know when they're connecting to a service that it needs this kind of an object, that kind of a serialization, and so on?
Yeah. So as Jayant mentioned, the service definition, the short answer of this is protocol buffers, right? So what we did was protocol buffer exists in the open source world for much longer and is widely used in the community. When we worked on gRPC, we basically added syntax for adding services and methods to protobuf syntax. So in addition to your data payload, you can define the methods and services. So just sticking with Giant's analogy, you can say RPC deposit money into bank account, takes in a bank account and a sum of money, right? So you define this method in the service definition, protobuf file. It comes with a compiler which is called proto-C, which basically does the code generation and gives you the stub where the developer, the user can say, okay, in my code, I'm going to say, this stub dot deposit money, and I know the arguments that it's going to take, right? So those are sort of pre-filled and given to you through the code gen process.
All right. Hey, I wanted to jump in if I could. You've mentioned a couple of times that this was written kind of learning the lessons of Stubby. Is the plan at Google to kind of phase out Stubby altogether and move to gRPC?
Yes. Over time, we'll phase out Stubby and move to gRPC.
Okay.
Now,
Go ahead.
There are tens of thousands of services, so that process is going to, and they're very mature. Stubby's, I work on Stubby too. Stubby is extremely mature, robust, so it's going to take time.
Mm-hmm.
And just so you know, Stubby is like the scale of Stubby is like tens of billions of RPCs a second. So it's across giant Google services. So it's going to take a while to move, but definitely the intent is to move over the next couple of years, and that is also speaks to our sort of seriousness about the project, and we think of gRPC as the RPC framework, not just something that we've thrown out there into the open source world, but as something that Google itself will move to.
Excellent. I looked through the languages that gRPC supports, and I saw C++ and Objective-C and C#, and I didn't see any love for good old ANSI C. Can I not use gRPC in ANSI C programs?
So if you look into the code, there are 3 native stacks, and most of the C++ code, in fact, the core of gRPC is developed in C. What we don't have is we have so we have this core library, and then we have this code generator and the high level stubs. So right now we don't have stubs in C, and we are in fact looking for some community members to help us build some C stubs. But if you want to use gRPC in a C program, you can use it as it's not as convenient, but you can use the core libraries for communication. And we're hoping for some community members to help us write the code generation and stubs for gRPC C2.
Very good. I'm glad to hear that. So what underlies gRPC? Is this a TCP stream, a UDP packet? How does that work on the underside?
So right now it's based on HTTP2 and HTTP2 using TCP, but and so it uses a subset of HTTP2 to communicate, and that helps us have a good ecosystem, a well-defined standard. In Stubby, we did not use HTTP or HTTP2, but we moved to HTTP2 in gRPC and have made sure all the benefits we got out of Stubby's proprietary protocol was still available through HTTP2. But we have also made the transport pluggable. So we have another implementation that we've been using. You can remove change the transport to be on top of other protocols. So UDP or some other protocols is possible. We've built one version on Quick protocol. Quick is type of UDP protocol, but that's how we expect this to evolve also. People may use different transports. Some people may want to use it just a shared memory transport. So those are things which you can plug and play in gRPC framework. And that's one thing I did want to say, that gRPC is built so that you can plug and play lots of different things. You can plug and remove the transport. You can change the data serialization format. You can change the authentication mechanism.
So it's built to be very modular. So you can, it's almost like playing with Legos. You can take whatever pieces you have and make it work with the kind of underlying gRPC stuff and Frankenstein together something that fits exactly what you need.
Exactly, because different people use different systems in their production environment, etc. Now, everybody doesn't use the same solution. At Google, we've benefited from having a homogeneous software stack, but as we go in open source, that's not what we expect.
You mentioned it's HTTPS 2. Is that encrypted by default? I can't remember.
Yes, so our default is HTTP2 is SSL encrypted. We do allow non-secure HTTP to be used, but default is encrypted, SSL encrypted.
Okay. That may answer the next question I had, but that is about security. So if I know that some server is listening for gRPC, what prevents me from doing a little bit of packet sniffing and then sending it some sort of malicious request? What's built into it to prevent that?
Yeah, so we rely on SSL encryption and SSL handshake for avoiding packet sniffing and people trying to steal and try to decrypt packets.
But if the attacker goes to connect to the open port, they can simply spit. So I suppose that does take care of sniffing. But if an attacker goes to connect to the open port, they can set up their own SSL connection and still try to say, hey, Mr. Server, I want you to run this command, and it's inside an SSL connection.
Right. So I think a lot of people do. There is authorization and authentication also. We do integrate OAuth 2 or JOT, etc. And so if the user is legitimate, they will have the required OAuth 2 token. This starts getting into the plug and play mechanism, how you deploy your service. Some services may need authentication. In that case, they'll use OAuth 2 or JWT, JSON Web Token type of authentication. And that's what will get verified by the user, by the server before trying to run that service. Does that answer what you were looking for?
I think so. The OAuth 2 bit is probably the direct answer to it, but it's always interesting to me as kind of a plumbing guy in some ways. It's interesting to see what other projects are doing to try to solve some of these problems.
Right. Yeah, I mean, this speaks a little bit to the pluggability, right? People use, OAuth, JOT tokens as a way to identify callers and receivers in any way today. So, you want to be able to allow people to plug into that. So one other thing pluggability was definitely one big design goal. And for something like RPC, which spans, which can be used pretty much in any environment. So another goal we had was to go cross-language, cross-environments, because all your various, when you're trying to make a fabric which connects various systems, you kind of have to do that. So that was another one of our design goals, and a third one which we haven't yet spoken about was spanning not just in and across data centers, but also to the client layer. So going all the way to mobile, and hence you see, support for Objective-C for iOS and Android Java for Android platforms as well.
Awesome. Hey, so We have a question actually from the chat room. We do have a live chat room that goes along with taping this show from the Andromedan. And he had a question similar to one I was going to ask. So I'll ask his and then add mine, which is, can gRPC be used with a load balancer? But I'll also enhance that question with, can it also act somewhat as a high availability service as well for service discovery that's always there? Whichever one wants to answer.
Jayant, you want to take that?
Yeah. gRPC can be used with load balancer. We use we envision two different models of load balancing. One is a proxy-based load balancing, and any HTTP2 based load balancer would work fine with gRPC. We also have and have been adding support for client-side load balancing, which is a look-aside load balancer. So you basically go to a look-aside load balancer, get some assignments, and then talk to your backends directly for certain piece of time. And we publish the protocol. So yes, gRPC can be used with load balancer, and most of the people do use it with load balancer. And actually, the second question was,
Just for service discovery and high availability, is this going to help with that, or do I need to have some extra solution to do my HA?
Yeah, so you probably need some people need more solutions for HA, but service discovery is partly done through sharing the same protocol buffer file from the client and server, and that's the contract. And we have added support for reflection, which lets you look through what a service exports. So you can find out what the service is and what the service exports. However, the naming or where is which service, etc., that is a plug and play solution, and different people use different solutions for that. People have integrated. We at Google use our internal solutions, but people have used things like Zookeeper, etc., to solve similar problems.
Yeah. So this goes back. People use Apache Zookeeper, etcd, Council. Like these are all like sort of popular naming services out there, and a whole lot of gRPC users have basically used. I suddenly went dark.
Randall knows how that goes.
Yep.
That is an energy-saving feature.
There we go.
That's called Google Smart Detection. If you don't move, it just goes dark. So I need to keep
yes. That's happened to me before.
Sorry. So yeah, we do have a way for people to plug in their naming service. So people have basically plugged in our name resolver interface and used one of these naming services.
Okay, we have a couple questions also from the chat room, and I have a follow-up to that one. Actually, I have a different one about protocol buffers, but and languages too. But let me not get ahead of myself. So the Andromeda, again, following up, says, will Swift be supported?
Yes. We have. Sorry, go ahead, Varun.
Either one.
Yeah, so in fact, it was very recently, I think we've added a repo for it, gRPC support in Swift. It's actually being sort of tested actively. I think we haven't made it public yet. It's sort of a private repo right now, but...
No, so we've made it public, and we welcome all the community.
Okay, so it's already out there. So I wasn't really sure, so I wanted to stay on the conservative side.
Yes. And I'm going to follow up with two more languages. One, where's the Perl? And second, what about Dart?
So the first one, we don't have any plans, Perl.
Not again. All right. Yeah.
Dart, I think we've talked several times. We just need we need some help from Dart expert community to help us build it. And internally, we've been talking, because the Dart team here is also wanting to use gRPC. It's in early stages of conversation, but basically Dart is waiting on people to contribute to the project.
So it's at the patch's welcome stage. If you build it, they will come. They will publish, I guess. So great. That looks good, because I'm seeing a lot more traction with Dart, especially now that the summit just happened, and seeing the two real products that are customer facing having rolled out from Google. Again, not things you can talk about directly, but or you may not be experienced with, but it sounds like this is the kind of thing that at least when you're using Dart server side, being able to do service discovery, serialization, things like that. So here's my slightly more complicated question. My only experience, I've got two questions about protocol buffers. So my only experience with protocol buffers was from a client about 7 or 8 years ago. And they were using protocol buffers to talk from the front end to the back end, actually from like the third layer of their back ends to the fourth layer of their back ends. It was very complicated. And they used protocol buffers. And when it was serializing Dart didn't exist back then, serializing Perl's hashes, it did it on the wire as key equals string, value equals string, hundreds and hundreds of times, depending on what the key values were. I'm hoping that protocol buffers either got smarter or it was just the client's idiot use of it. Can you help me forward with that question?
I'm going to guess, but I think that has to do with the Perl implementation of protocol buffers. So protocol buffers has a fixed wire format, and how arrays or maps, etc. And we've been adding stuff also, like maps, one-offs, etc. are newer features, so they probably didn't exist then. So I don't know much about Perl. I don't know Perl and Perl's implementation of protocol buffers, but my assumption is the Perl library for protocol buffers took the hashes and converted it to the key value pairs or repeated key value pair messages, and that's why it was looking like that on the wire.
Well, if you don't know Perl, I can recommend a couple of good books. At least that's what they say. That's what they say. It's not what I say, although I wrote them. But so it sounds good, though. It sounds like you've moved forward with protocol buffers. And I noticed this has gone on to be Proto 3 instead of Proto 2. Can you describe the differences between the two and why I might be a lot more excited about Proto 3?
Yeah, so Proto 3 is simpler. So one of the things of learning is also you learn which features were adding a lot of complexity to what you were doing. So we've been using protocol buffers also for a long period of time, and we realized some of the features were adding a lot of complexity. So we've removed some features and then added features like canonical JSON conversion, so we can have a idiomatic idempotent conversions to JSON, so from protocol buffers to JSON and back and forth. And we've added lots of support across different languages. So those are kind of the key features. The features that have changed are we've removed has bits and some details. I don't think it makes sense going into those here.
Okay, so actually that was sort of a good follow-on. So does Proto 3 understand things like a JSON structure? Because I'm sure you're throwing a lot of those around these days.
So Proto 3 can so Proto 3 libraries can convert to JSON and take JSON as an input. Now it's not any arbitrary JSON or any specific. That JSON is basically a subset of JSON that works well in this one-to-one convergence with protocol buffers. Okay. But then you can use JSON in your application.
And we have a question also from the chat room. Luddite asks, does gRPC compare with a client service program like MQTT? My guess, if I can just take a wild guess at the answer to that, but you can verify, is that gRPC might be used to talk to something like a queuing service, but it isn't itself a queuing service. Am I correct?
Yes, gRPC is not a queuing service.
Okay, so you might set up something like a gRPC connection to your favorite, like Rabbit or something internally, then, right?
Yes.
Ah, very cool.
And for we do that with our own PubSub service.
Okay. We had and I'm going to forget their names. Never mind. Okay, well, I'm not going to ask that question then because I'm getting old apparently. So 55, apparently it's all half-life from here on out. So I've asked my protocol before. So what somebody actually asked is this what's the difference between this and Stubby? And I'm guessing the big questions is that, or big answer would be, well, Stubby was internal and proprietary. Did you also change things as you were migrating from Stubby to gRPC? Was it upward compatible, so it could just be a drop-in plus or minus some code changes?
No, we rewrote it from scratch. Stubby was very proprietary, and we also wanted to rewrite because we wanted to. So some of the things in gRPC, like bidirectional streaming, etc., are really things that we also wanted to get into Stubby. We had some versions of those in Stubby, so we wanted to rewrite, and so gRPC is not compatible with Stubby. So we have the same problem as several people who are trying to use gRPC run into, where, hey, how do I migrate? And we're trying different solutions for that. But gRPC is a completely different system, brand new system built from scratch.
Yeah, and speaking of differences, right, like some we alluded to, like standards-based first-class support for bidirectional streaming, first-class support for mobile, Android and iOS, and supporting multiple languages and environment. Like in Stubby land, we could be more homogeneous because we were within Google. Out there we need to support more. So those are some differences.
Hey, I wanted to jump in if I could. So one question that we haven't hit yet: what license is gRPC under?
It's BSD 3.
Okay, all right, got it. So I've worked with some of these web-based APIs in the past, and a lot of them have this feature where you can make queries straight from a browser, or you can write queries from wget or curl and kind of build it into shell script that way. Does gRPC support anything like that?
Yeah. So I think there's two answers to that. One, I think Jayant alluded to, which is sort of a reflection service, and this is by language. So the ability to sort of poke a gRPC service and say, okay, what methods do you support? Here's a test request. Give me a test response. That is out there based on language. The readiness varies. The other one is can I just test from browsers? That's active work in progress. We actually have a variant of gRPC which we call gRPC Web, which we are actively under sort of alpha testing, and so that will allow people to have browser clients not just for testing, but like as full-fledged browser front ends talking gRPC Web to backend gRPC services.
Will that expand to something like being able to have a curl string? So you use curl to do a request over HTTP2, and it does something, and then perhaps sends back something that a shell script can interpret.
Right. So the command line interface, actually, we have a CLI tool right now, which is based on the reflection that Varun was talking about. So you can use the CLI tool. For the browser, the reason it's taking longer is we can't use all the features from a browser of HTTP2 right now. So we are trying to figure out how to use from browser. People also have used, before even we got in, there are projects like gRPC Gateway, which people are using, and they're using that to, this was a third-party contribution, and people are using those to talk from a browser too.
Yeah. And talking of third parties, is people have built their own sort of CLI tools for this kind of testing as well. And so, one exists in Java called Polyglot.
Okay, sounds very useful. You mentioned something a while back using gRPC from mobile applications. What's the advantage of gRPC from mobile?
So it's the make advantages are basically network and performance. So when you're making requests, especially if you have streaming requests to your backends. Today, most of the apps end up doing long polling, which has an effect on data usage, has an effect on battery usage. So we think gRPC can help in some of those. In fact, some of the recently launched Google apps like Allo and Duo, which are our sort of, messaging and video communication apps, actually use gRPC from their mobile apps. So it's something which has started to go out there into production use, and some external community is also picking up on that. But yeah, the main benefit would be around saving data and battery on the device side, being able to operate in somewhat unreliable, harsh network environments as well. So, if you go to think around emerging markets and unreliable networks, you need to have even more smarter abilities to retry, cache, compress, etc. And we're working on some of those to add on to our mobile efforts.
And I would like to add one more. I think it's just at basic, it's the same simple programming model. You can use the same model to write your mobile applications that you use to develop other parts of your stack. What we found in past at Google was people wrote services using Stubby, and then they had these application front ends which spent a fair amount of time converting this into some other format, and they had to design another contract between their mobile application and the front end. So just having the same model really helps and speeds up the application development and makes it easier too.
Cool. Hey, so what about retransmit and timeout and things like that? Can I just set a value? It says if you don't get anything back in 30 seconds, try again at the lowest level, or do I need to handle that higher in my code?
So gRPC has deadlines. So what it does is you can specify a deadline, and that deadline propagates, which is a really cool feature. And then it cancels also if you cancel the operation across the graph. You can specify a deadline for RPC, and then if the service that receives the RPC makes another RPCs for that RPC, it creates the newer deadlines based on the original deadline and sends those newer deadlines. So you create a graph of these deadlines with different values which get calculated for you. And if you decide to cancel RPC, all of these everything gets canceled. So that's a really neat feature. People like it a lot of gRPC. What was the other question?
No, I think that answered most of it. But I also then want to ask, since you brought up, one of you brought up that it was being used in Allo and Duo and things like that. Is this good for push notifications? Does it work well with this sort of a structure?
It works well when the biggest advantage people see is when they want to have a chat-like application.
Yes.
That's when the streaming and bidirectional streaming features of gRPC really help the application development. It works well for push notifications also, but the benefit is much higher when you have a chat-like application.
And so that begs sort of the next question, which is, what about topologies? Is this good for one-to-many broadcasts or many-to-one gathering? Does this work? Are there gRPC topologies like this?
No, right now it's point-to-point.
Okay.
We've explored it internally, but gRPC is point-to-point.
And so I'm wondering why you didn't look at maybe some other technologies, although you'd probably be duplicating things like, ZeroMQ has a great wire protocol and was supported across multiple languages. Unfortunately, it's, I don't want to say development is dead, but it's sadly that may be actually what's true. But it had those sort of fan outs and had good wire protocol and good management. Did you look at other things before saying we're just going to make Stubby smarter, or am I oversimplifying the process?
We looked at other things. I think what we found was when we were starting on gRPC, HTTP2 was not defined, and a lot of things that we wanted were present in HTTP2, and it had this very nice standardization as well as working with the ecosystem, with working with existing proxies, etc. Benefit. That's why gRPC took the direction that it took. Regarding fan out or things like that, we just haven't spent enough time developing that type of solution yet. But we'll look at ZeroMQ also when the time comes for that.
Yeah, and some of the guys that worked on ZeroMQ are off working on other things that are named similar to ZeroMQ, and I want to get one of them on the show at some point here. But now it's not in front of me, so of course my 55-year-old brain says, no, I don't remember what this is. We're almost out of time. I do have like one other thing. So does the RPC library itself, gRPC library, does that manage reconnection and retransmit? I mean, you're talking about mobile apps where, sometimes you go through a tunnel and now all of a sudden you're not connected anymore for a second or two until you come back on the other end of the tunnel. Does gRPC handle that for me, or am I going to get a notification like I'm disconnected? I got to go through my own reconnect logic up at the upper level. Where does that have to get done? So
it does reconnect. If you don't have a RPC in flight, it reconnects it whenever it understands that connection is broken. It does exponential backoff and tries to reconnect. Okay. If a RPC is in flight, then it depends on what the RPC was going to do. And the retry facility is something we are adding, but it's more complex than retransmit because you need to make sure that the other side did not receive or did not take action, and duplicated RPCs are okay.
Right. So you want to have, do you require then idempotent requests, or if I just said increment by one, am I guaranteed to only get one no matter how much it has to figure out stuff underneath?
Right. So I think our retry policy will determine that we'll have some retry if we can prove. So the solution would end up becoming, if we know for sure that the RPC didn't reach the server or server didn't handle it, then we can retransmit it whether idempotent or not. If we cannot guarantee that, then we'll only do it for idempotent RPCs, which would be somehow annotated in protocol buffer. So,
okay, very good. Well, like I said, we're almost out of time. Is there anything that we haven't asked yet that you want to make sure our audience is aware of before we let you go? Both of you. Either of you.
So I would like to talk about, along with gRPC, we have also started a organization called gRPC Ecosystem. And gRPC is a project where we can really benefit from all these. I was talking about this plug and play, and different people use it in different, they do different types of integrations, etc. And we would love people to contribute and share how they're using gRPC with others, so that there are always different people. A lot of time when we talk to people using gRPC, we realize that, A wanted to do same thing as C, and it's we would love those people to contribute in that organization. We've created an org for that, so I wanted to do a pitch for that organization.
Excellent. Varun, same question.
Yeah. No, I think we touched upon most of the things. It's of course, it's at a stage where we feel core is stable since it's 1.0. We obviously will keep adding based on roadmap. But it's at a stage where we can love community integrations with other projects, even other languages. So if you feel excited about adding Perl support, go for it.
Well, first we got to get protocol buffers up to Proto 3. Right now it's only at Proto 2, so that would be the first part. I do not want to try that at all. So, but yeah. Anything else?
Serious note. No. I think we covered most of it. Yeah.
Awesome. And 2 more questions for both of you, because otherwise I'll get yelled at. So what's your favorite scripting language, and what text editor do you use primarily? That would be first for Varun.
VI. Emacs.
Okay.
Emacs people don't hate me. I know there's a...
Too late. And scripting language.
It's just... scripting, I actually do like Perl, to be honest. Haven't used after a lot of the initial college days, but yeah, I do like it.
Okay. As a former programmer, you like Perl. That's great. Okay. and Jan, same questions.
Yeah, Vim is my favorite editor.
Yeah.
And Python. I use Python.
Indented properly. Indented as Guido indented. Yes, exactly. All right. Yes, very good. Well, you guys, this is great. I'm sure there are some people now who are thinking about reaching for the gRPC toolkit when they want to build themselves applications that jump out over processes and jump out over machines and things like that. So thank you both for coming on the show and talking about gRPC with us.
Thank you.
Thank you for having us.
Awesome. So that was, if I can pronounce it one more time or mispronounce it one more time, Varun Talwar and Jant Kolhe. I think it was something close to that. Jonathan, what do you think?
It's a fascinating project. It sounds like they have looked at this concept of making 2 different applications talk to each other, and they've tried to go in and take care of all the hair, because that's a hairy problem. How do you make 2 things talk to each other across a network when you might be dropping packets, et cetera? And it's like the project is trying to remove all the hair and then give you a very nice package at the end that says, all you have to do is you call this and you throw some data into it and we make the rest happen. So it sounds like it's going to be a great tool for all of us that occasionally have to hack on projects that need that. It's a great tool to have in our toolkit. And so next time I'm working on either a mobile app that could use it, or even something infrastructure related, making 2 servers or 2 VMs talk to each other, I'll definitely keep it in mind. It sounds like it could be very useful.
Yeah, well, it'll be really useful to some of my clients once they get a Perl implementation. But I do want to say though, I really appreciate it when when some organization the size of Google says, we're using this thing and it's solving problems for billions of our internal connections a second. Or will be if it isn't already. And we're going to open source it too, so you guys can contribute to it and maybe use it in ways we weren't expecting, and maybe integrate it into other solutions that you might have. I think this is sort of open source at its best. This isn't as we've seen in some previous shows. I won't name names, but some previous shows where it looks more like they're open sourcing maybe abandonware, or they're open sourcing in name only. I didn't ask, although like I said, the show's over, we're running out of time here, about things like, well, who decides the roadmap? I imagine Google's going to have a strong hand in that, but I mean, if someone discovers that maybe something about, gRPC 2.0 ought to also incorporate something like fan in, fan out and things like that, and provide the code, and it's transparent and stuff, I don't see why Google wouldn't, strongly consider that, or at least as a committee, as a group, they could then say, yeah, this looks like a great way for gRPC to head in terms of direction. So I think this is not open source in name only. I think Google does open source in a very good way. So I'm very happy that this is yet another project in that arena. Anything else, Jonathan, before I start running through the closing parts of the show?
Sure. This is something I've seen from Google a lot. They actually seem to get open source. I'm not sure what it is about their corporate culture that allows them to, but they have some people that really understand how open source is supposed to work, and they've got a lot of projects that support it well. And it's one of the things that I'm definitely a fan of that they do at Google. So good on them.
Well, I would have to say that probably a substantial part of it is due to the creator of this show back in the day, back 10 years ago. Can you believe the show's been going for 10 years? Krista Bona, who is still the open source sort of advocate and senior MIFWIC there, taking care of things for the open source community, at least as far as I understand. He may have actually just changed to a job where he just shows up occasionally and doesn't even dress up except in Google clothes. I don't know. I have no idea. But he's significant to Google still enough for them to pay him. So that's a good thing.
Maybe we can have him on and ask about it.
Yeah. We can have him explain, has your job changed since you're no longer on this show? Excuse me, got a little frog in my throat there. Let me continue on then by talking about who we got coming up. We have next week, we have Minoka, which is a general purpose OS from scratch. So we're talking about something that's mostly POSIX compatible on the user facing side of it, but it's not Linux. It's not based on Linux code. It started from scratch and it runs already on x86 and ARM. And so we'll have some people there talking about what they're trying to do. I'll probably try to get an ARM person on so we can talk about the ARM implications of that. Following that, Koala, which is linting and fixing code for all languages, which should be pretty cool. So kind of putting an umbrella over all the tools. Like I've got a project that has HTML in it and Python and maybe some sort of maybe even protocol buffers. How do I run one tool over everything to either tell me what's wrong or fix it if you can? And there's certain things that can work really well at. Twine, which is a follow-on to our show we did about interactive fiction a few weeks back, where you have basically those stories that are choose your own adventures. This is a really slick tool that you can both use Twine hosted essentially for free and build your own interactive story, or you can just download the whole kit and caboodle and run Twine for your own benefits. Maybe your next user manual for internal is an adventure game. That would be something that would get you fired. So, but you can do it with open source software. That's the best part. All right. OpenHMD, which is head-mounted displays, things like the Oculus and Google Glass and Google Cardboard and those things, basically abstracting all the protocols required for all that stuff. OpenNMS, which is carrier-grade network monitoring. Think things like Ichinga and stuff, but scaled to a grand scale and probably a little bit older. I think the OpenNMS project goes back actually all the way to the beginning of this show, if not further, because I remember OpenNMS was one of the very first shows that was done even before I became the host. So back when Krista Bona was the host. So back in the day. Eclipse Shay, which is a developer workspace server and cloud IDE for Eclipse. So you can have cooperation, collaboration. There's also a hosted solution available for it. We'll talk about that. That's CodeNV, a company that wants to make Eclipse easier for everyone to use. More being added all the time. Twit.tv/floss is the homepage for this show, and linked from there you'll find my big spreadsheet that shows my work in public about what I'm trying to do to get everybody on this show. Still booking a couple of slots left in Q4. I think actually one of them is going to be taken within the next 48 hours. And also opened up Q1, so I've got a couple months open there, so I'm going to be sending out my flurry of messages hopefully this weekend to get more people booked. We have a live stream at 9:30 a.m. Pacific time on Tuesdays at live.twit.tv, where we took a number of questions today. You can follow us on FLOSS Weekly on Google+, and at FLOSS Weekly on Twitter. Automatically tweeted over whenever I post something on FLOSS Weekly. The Google+. You can follow me at Randall L. Schwartz on Google+, and that is also automatically tweeted over to Merlin, M-E-R-L-Y-N. It's also automatically posted over on Facebook, if you happen to be one of those millions of Facebook users that can distinguish fake news from real news. I am going to be, so far, coming up this year, we've got YAPC and OSCON. YAPC in D.C. area, so I'll be in the D.C. area sometime in, I think it's June or July. And OSCON is in Austin again this year, again, probably in the middle of summer. So it'll be like 90, 100 degrees again, darn it. And probably also be at a couple of other conferences. I'm hoping again to go to DragonCon this year, even though I missed it last year because I was temporarily hospitalized. And also hope to go to Brazil if they get rid of the Zika virus before I come down, because I don't want to be the carrier there. That's why I canceled last year. So hopefully 3 or 4 or 5 public places that you'll find me, but nothing immediately on the schedule. Anything you want to plug, Jonathan?
Am I allowed to give a shout out to something that's not mine, but I found interesting?
Yes.
Okay. I came across a college level course called NAND to Tetris, and I found it very fascinating. I believe their software is open source. I'm not 100% certain of that. I'm pretty sure it is. But it's the idea of starting with NAND gates and building all the way up to building a 16-bit processor and running code on it. Very cool project. Go check it out.
Oh, that does sound awesome. Yes. Always interested in things that are Maker and breadboard and things like that. So all good stuff. I'm sure actually Aaron would be excited by some of that as well. But Aaron's not here. You're here, Jonathan. Jonathan, thank you for joining me as the co-host for our third to last show of the year, maybe fourth to last show. One of the final shows of the year. Well, some number of shows still left to be done.
Math.
So thank you again for joining us for that.
Yep, always my pleasure.
Very good, Jonathan. And stay warm and fuzzy. No, that doesn't make any sense. Stay healthy there in good old Oklahoma. And I'm going to go rent a new brain. We'll see you all again next week on FLOSS Weekly.